Hello.
Hello, everyone.
Welcome to the Citus 12.0 release party live stream. I'm Claire Giordano, and I work on the Postgres and Citus teams at Microsoft.
Hey, and I'm Marco Slot. I'm a software engineer at Microsoft and architect of the Citus project.
And we're your hosts for today. But we're not the only ones here. We're going to be joined by several other people, and we're going to be talking about schema-based sharding in Citus 12.
Yeah, it's Citus 12. It's a major release. Like we do one of those per year, and that always comes with some, say, fireworks. And this time it's the schema-based sharding feature. I'm actually really excited about this feature. And it's all about making it very easy to horizontally scale your Postgres database across many servers. So the basic idea is that you can, you have Postgres with Citus, and then you enable a setting, and then any schema you create, the underlying data could be placed on any of the nodes in the cluster, and it's all transparent to the application. So both the querying is transparent, so the query will get routed to whichever node stores the schema, but also the data modeling is completely transparent. You just create schemas like you would in Postgres. Maybe this is already how you use Postgres, and under the covers, the schemas get sharded across the cluster. And that just makes it much easier to use Citus for certain use cases, but also it actually enables new use cases that to scale across many servers.
And when you say for certain use cases, you're talking about multi-tenant SaaS applications, microservices applications.
Yeah. So a common one is multi-tenant. So software as a service, like every tenant gets their own schema. Maybe some tenants have a slightly different schema than others. That's where schema-based sharding is very helpful. And then if you have lots of different microservices, but you actually don't want every microservice to have its own database, but you'd rather consolidate that into a single place. But at the same time, you want to be able to scale as your microservices grow or you add more. So that's a good example. Also, if you have a more complex application with different functions, one is focused on, let's say, the shopping cart, another on orders, another one on reviews. Often those are actually kind of different segments of your database that you could put in different schemas and then actually scale across nodes that way.
Cool. Well, we're going to be joined by a couple of different engineers on the Citus team today. Owner is going to start. He's going to talk about how to enable schema-based sharding in Citus. Then Gokhan will join us to show us some of the tenant monitoring improvements. And then ML is going to join to talk about a change in PgBouncer that enables schema-based sharding for Postgres. So I think we should probably dive in, right, Marco? Did I miss anything? I think it's time to welcome Owner to the screen. Hey there.
Hi, Claire. Yeah, so today I'll be demoing some cool features about schema-based sharding, especially the things that users need to know to start sharding their PostgreSQL database based on their database schemas. And along my demo, I'll be acting as a data product provider to retail stores. And my expectation from my database is my first expectation from my database is to be able to represent my customers in separate schemas. And also my second expectation is to be able to easily shard my database based on schemas, each correspond to a different customer. So let me get started with my demo. Then let me connect.
Welcome back, Marco.
Yeah, sorry, we got fiber a few days ago, but it still has some issues.
Adjustment issues.
Welcome back, Marco. So assuming a case where I have a new customer, they are which is smart spenders. I would like to create a separate schema to do the bookkeeping for that to do the bookkeeping within data tables via data tables that I will create within that schema. But before doing that, first I need to enable this brand new configuration variable, which is citus.enable schema-based sharding. While this setting is enabled, any schema any newly created schema becomes a distributed schema in my Citus cluster, or in other words, becomes a logical shard of constitutes the a logical shard of my database via the data tables within that schema. And then let me set my search path to smart spanners, because I'm about to create some data tables within smart spanners. And then my first table would be orders. Yeah. All right. I guess I didn't create my schema. Okay. And then let me make sure that I have created it. So yeah, it is great. Okay. Then we are in the smart spanner schema, and then let me create some data tables within that schema, and the orders and order items, and then the payments table. And now if we query the Citus tables view, as I did a few seconds before, but let me first reset the search path. And if we do query the Citus schemas view, we can see the smart spanners in the output of this view as well, like together with the other schemas that I have created before starting my demo for demo purposes. And if we query the Citus tables view, we can see that each of those distributed schemas do have three distributed tables, which we call as schema distributed tables. And actually, they are distributed in a bit unusual way, such that they don't have a distribution column, and as a result, they do strictly have a single shard. But sorry. But they are distributed in a way that they can be moved around in my Citus cluster, and also the collocation ID column that we have also seen in the output of Citus schemas view is actually used to ensure that the tables within a specific schema always be stored on the same worker node, whatever kind of shard move or shard rebalancing operation happens in your Citus cluster. And let me load some more data into smart spanner schema, because I would like to simulate the case where one of my tenants got bigger and bigger when compared to my other customers. And in such cases, you might end up with in a situation like you might end up with a bit unfair distributed schema distribution in your Citus cluster, because what Citus does upon creation of your distributed schema is that it places the first schema into first worker node and the other one into second worker node in a round robin based on a round robin based approach. So if we query these Citus schemas view one more time, we can see that the size of the data tables within smart spanners is nearly equal or greater than the other three customer schemas. So, and if we query the Citus shards view, we can see that due to that simple round robin based approach, the data tables of Schema-Polis and smart spanners are stored on the same worker node. However, it would be ideal to maybe put smart spanners into one worker node and the other three into another worker node, assuming that I'm using a Citus setup with two workers. So, but in such cases, I can very well benefit from Citus background Citus rebalancer, as well as we can also, as well as users have already been benefiting from in the row-based sharding world. So if we start this rebalancer in the background, and if we query the status of the shard rebalancer, and it has been completed now, we can see that data tables within Schema-Polis have also been moved to the first worker node. To the worker node that contains the other two small customers, budget buyers and Mega Save Mart. And also, I also would like to run a kind of simple join query that aims to find the amount of milk and cheese that we have sold to smart spanners in 2022. So for that, use that query which joins order items orders table and the products table, which is a reference table that I've created in the public schema. And we can get the result, and we didn't need to add any kind of tenant ID or shard key column filter into the var clause. And apart from that, if we run this query with explain, we can see that all the query got pushed down to the worker node that contains the data for smart spenders. And this actually brings a good amount of flexibility in terms of SQL support, because as long as your query targets a single distributed schema, which would be the case mostly for our use case, you would almost get no SQL limitations at all inside this context.
So we now have this concept of a distributed schema, which you get by enabling schema-based sharding. But what if you didn't enable the setting, you forgot, or you just already had a schema, or what if you didn't actually want that?
Yeah. Thanks, Marco, for asking this. Yeah, for such case, we have also added a Postgres function to allow a smoother user experience for such cases. Like if for example, if the user has had some existing schemas in their Postgres database. So, for example, if I create a brand new schema for my new customer, let's call it simply new customer, and then I can very well use that Citus schema distribute function, which allows us to make a distributed schema from an already, but maybe I did a mistake. Like, let me drop that schema again, and let's say disable that schema-based sharding setting to off to simulate the case where I forgot to enable this setting. And then if I create this schema, I can very well use this Citus schema distribute function to distribute that existing schema. And so, yeah, new customer. Sorry. Yeah, in such case, this function can be used to distribute your schema.
Cool.
Yeah, and likely we also have added one more function to help with a similar scenario, which is Citus schema undistribute, and that would actually be mostly useful in the cases where, for example, you are playing with this new schema-based sharding feature in Citus, like you're doing some kind of experiments in your Citus cluster. You have distributed some of your schemas to see how it would work, but then you have decided to not distribute some of your schemas for some reason. Like maybe it would be okay to simply store that tenant in the coordinator node as a regular PostgreSQL table. And if we run this Citus schema undistribute function, what it does is it would simply pull all the data tables within that schema back to the coordinator as regular PostgreSQL tables. And for example, now I undistributed smart spenders schema for some reason. And if we query the Citus schemas view one more time, we can see that smart spenders do not present in the output of Citus schemas view anymore. And I think those are all the things that I wanted to talk about today. And I guess back to you, Claire and Marco.
Thank you. I really like that you focused on how to use or how to enable the new schema-based sharding feature, because for multi-tenant SaaS microservices applications, this presents an option that's much easier to onboard to, depending on how they're using Postgres. So I think that's super cool. But my question, and I'm not sure if this is for Owner or Marco, maybe Marco, is, so what about row-based sharding? Is that still a good option for some applications when they're using Citus to scale out Postgres?
Yeah, I can take it. It's definitely like schema-based sharding is additive to row-based sharding. So you now have both of these amazing capabilities, and you can use them whichever you prefer. You can mix and match them. You can have some like row-based sharding. We now mean like hash distributed tables. We didn't really explicitly refer to that as row-based sharding before because there was only row-based sharding. So sharding was row-based sharding, but now we also have schema-based sharding. And for any application that needs like a really large table, IoT applications, real-time analytics, that's still the thing to use. But now there's other applications such as microservices, which each have their own schema where, I mean, it wouldn't make sense to put that in a single table, but it makes a lot of sense for to use schema-based sharding. And then there's one class of applications, the multi-tenant applications, where you actually have a choice. Like traditionally, Citus users have done row-based sharding, and now you can also pick schema-based sharding. And there's some differences, like schema-based sharding, as Owner mentioned, it's just much easier to use. Like you just create schema like you would in Postgres. It also has some other benefits, like you can have different variations of your tables for different tenants. Row-based sharding, you have shared tables, but they're distributed by a tenant ID column. And you have to make sure that column appears in your primary keys and foreign keys and joins. And so you may have to adjust your data model and your application to use it. But the advantage is then that it easily scales to millions of tenants. Whereas with schema-based sharding, if you have millions of schemas, like you might start seeing a lot of overhead in Postgres. So that can be a downside. So up to like 10,000 or tens of thousands of tenant schema-based sharding works very well. But beyond that, you should think of row-based sharding. And if you've already used row-based sharding, perfect. Just keep using it. It's great. Owner, I had one question. It's like, what is, you're probably the best person to answer this. So are there any downside to distributing a schema? Like, so I can enable it or disable it, but if I just keep it enabled, are there things I cannot do in a distributed schema?
Basically, like in terms of SQL or DDL support, like most of the things would I expect most of the things to simply work. Like as long as, for example, you're joining your query that contains a join single z-target schema, or maybe plus some reference tables, it would just work. Or most kinds of the foreign keys within a distributed schema would also just work. But for example, if you for some reason want to join, for example, orders tables from different tenant schemas, that might not be supported for all the join scenarios. But yeah, as long as it is a single distributed schema, there is not much downsides of using that, except maybe like if you compare this with the row-based sharding model. Row-based sharding scales in a better way because like having lots of tables or lots of schemas do introduce some overhead to Postgres. But yeah, it is more like a trade-off between ease of use and less overhead maybe. But yeah.
Got it.
Awesome.
Thanks.
Well, thank you for joining us, Owner. We really appreciate the demo.
Thank you.
That's great.
And now we want to welcome Gökhan Gulbiz to the screen. Welcome, Gökhan.
Hello.
You are going to give us a demo about some of the tenant monitoring improvements in Citus 12.0, correct?
Yes, that's correct. Let's talk about it.
Right. But so tenant monitoring was kind of introduced in 11.3, right? So
well, that's true. We introduced the Citus.tenants view as a tenant monitoring purposes in 11.3, but for this release, we have introduced significant improvements to the tenant monitoring feature, not only limited to supporting schema-based tenants, but also performance optimizations and data sampling feature.
Cool.
And today, let's talk about it. So, before jumping into the demo, I would like to mention about why tenant monitoring is a crucial aspect of optimizing databases, particularly for multi-tenant SaaS applications. It allows you to gain insights into the usage data of individual tenants, which is invaluable for resource allocation, optimization, and overall performance improvements. In a multi-tenant environment, ensuring tenant isolation and dealing with the noisy neighbor problem are critical challenges. And tenant monitoring plays a pivotal role in addressing these issues. So we can switch to my screen right now.
Okay, so wait, noisy neighbor problem. Can you give that just a one-sentence definition for people who aren't familiar with the term?
Sure. Let's say you have more than 10 tenants in your cluster, and one of them takes so much workload and prevent the other tenants to perform properly. So
Okay.
the question is, how can you define the noisy tenant? The tenant has unexpected workload. That's what the tenant monitoring helps you to define those kind of problems.
Cool.
All right. So first thing first, tenant monitoring is off by default. So you should enable it before to see the tenant metrics in the Citus stat tenants track view. So to do that, you just need to set the Citus stat tenant track configuration to all in the Postgres.conf file. And with the setting, you could monitor your tenants across all Citus nodes and backends. For my cluster, I already enabled it, but just to make sure that it's enabled, there we go. Right now, tenant monitor is up and running. So right now, I do have two distributed tables, row-based sharded tables, I can say. And let's see their distribution column. So right now, as we can see, I have campaigns table. It's a distributed table, and its distribution column is company ID, and also I do have a companies table. It's the same configuration, and its distribution column is ID. So let's run a few queries to generate a workload, and then I would like to show you the Citus stat tenants view. Here is a couple of queries I just executed. Please do not pay attention to what kind of queries are those. These are only basic insert, update, select queries. Is just for demonstration purposes. And then right now we executed a few queries on our cluster, and let's see what our tenant monitor will show us. Right now, as you can see, we can see the read count and query count and CPU usage in seconds. As I mentioned, these tables are row-based sharded tables, and this is what we have with Citus 11.3. And with the latest release of Citus, we also have schema-based tenants. So right now, I would like to show the capabilities of tenant monitoring with schema-based tenants, but we also have a few GUC settings to modify the let's say the number of tenants to be tracked by the monitor. Its default value is 100. So let me show it. You can modify these settings to specify the maximum number of tenants you wanted to monitor in the Citus stat tenants view. And also, moreover, to control the length of the monitoring periods, you could adjust Citus stat tenants period, and it's by default a period passed every 60 seconds, and statistics were updated accordingly. However, you had the option to change the period length as per your specific monitoring needs. And also, just to mention about it, we do have a UDF to reset the tenant monitor. It's called Citus stat tenants resets. And right now, I just resetted my tenant monitoring. So with the Citus v12, we now fully support schema-based tenants in tenant monitoring. And these enhancements means you can gain insights in the individual tenant behavior and resource utilization at the schema level, offering a more granular view of your multi-tenant SaaS application. So let's create a schema and see how tenant monitoring works with it. Right now, I just created a schema called tenant A and two tables And this is just right now, it's just a regular schema, and let's distribute it. To do that, I will call Citus schema distribute UDF. Right now, I have a distributed schema and 2 tables in it. Let's run a few queries to generate workloads on this schema. Again, please do not pay attention to these simple queries. Those are very simple insert select queries. So right now, we would like to see the tenant monitoring results, right? Before viewing the statistics of a schema-based tenant, what would you expect to see as the tenant identifier in the results? That is my question. Because as you can see, we haven't specified a distribution column or distribution key. We just created a schema and distributed it. So in this case, sorry, Claire.
Oh no, is it a rhetorical question? Are you going to tell us the answer?
Yes, I will tell it. So actually, the answer was in the question. As I mentioned, schema-based tenant. Right now, our tenant is our schema. So tenant monitoring will show a single row for our distributed schema. Even we have more than even we have 2 tables. The results will be aggregated into a schema level. So as you can see right now, our tenant attribute is tenant A, and this is the read count, and this is the total query count, and this is the CPU usage in seconds.
And so is there a way to tell like which of these records are schema tenants and which are row-based tenants, in case you were using both on the same cluster?
Sure. I mean, the best way to identify if it's a row-based tenant or schema-based tenant, we can join this view with Citus _ schema view to be able to identify which belongs to what.
Got it. Makes sense.
All right.
So when you say CPU usage in seconds, that's like this many seconds of CPU were used by this tenant in 1 minute.
Exactly, that's true.
Right.
Exactly, that's true.
So if it goes to 60, you're kind of in trouble.
That's true. It means that you are using the full CPU capacity. That's true.
Makes sense.
And apart from supporting schema-based tenants, we also made significant performance improvements to the tenants monitoring. And one of the major optimizations includes the use of a better data structure and locking optimization. By leveraging a more efficient data structure, we have reduced the overhead of tracking tenant statistics up to 30%, resulting in improved performance. And these performance improvements ensure that tenant monitoring has a minimal impact on your database performance, even when monitoring a large number of tenants. And here is the last feature that we introduced with version 12, and it's called data sampling in tenant monitoring. We understand that finding the right balance between monitoring and performance is crucial for our customers. That's why in Citus v12, we introduced data sampling feature for untracked tenants. To set the sampling rate, we introduced a new GAG setting called stat tenants untracked sample rate. It expects a double value. To clarify the sampling process in the tenant monitoring feature, it selectively samples queries for new or untracked tenants while ensuring the comprehensive query tracking for all previously tracked tenants, which means that the sampling rate option only triggers sampling for currently untracked tenants, allowing a balance between through the monitoring and reducing the performance impact on the system. And by enabling data sampling, you can ensure that tenant monitoring is both efficient and accurate, providing valuable insights without causing unnecessary strain on your Citus cluster.
So one of the challenges I always have with controls like this, in this case, a setting that allows you to set the untracked sample rate, is figuring out what to set it to. Is there a great docs page, or what's the guidance for people if they want to use this?
Well, the safest option is starting with sampling rate and then observing your TPS performance. And then you can, I'm sure that you can find the sweet spots for that, for your workload or for your business needs. Because, I mean, there is no one rule to fit all case for this sampling option because it heavily depends on the workload type and the tenant distribution. So best case is just by modifying this configuration and finding the sweet spot for your cluster.
And do you have a sense what is like the typical overhead of enabling the tenant monitoring?
Sure. Based on our internal benchmarking results on a 16 vCore and 2-node cluster with 1 million tenants and with 10% sampling rate, our overhead is around 3%, which is nice, I think.
Yeah, that's really good. Yeah, I think recently I saw, I don't know if it was a Hacker News comment or a blog post, but like someone was asking like, what is the overhead of all this telemetry? And the answer was like minus 150%, because after adding this telemetry, things just got so much faster because we knew actually what was slow and what was causing the slowness. So it's like, it's that 3% quickly comes for free if you can start tweaking your system based on that.
Awesome. Well, thank you, Gokhan, for joining us today. Really
You're
appreciate
welcome.
the demo.
Yeah, that was
Pleasure
great
for me. Bye.
Bye-bye. Now we want to welcome Emil Shimshake to join us here on screen. Hi, Emil.
Hi. Hi, everyone.
So you're going to be doing a demo about PgBouncer, and specifically something that changed in PgBouncer to support schema-based sharding in Citus. Is that right?
Yes, that's true.
So what does PgBouncer have to do with schema-based sharding?
Yeah. So as shown earlier, with schema-based sharding, applications are going to add their tenant names to the search path before running their queries, right? And if there is PgBouncer between your application and the server, the search path does not work as expected in all the configurations. So we wanted to fix this for our schema-based sharding use case, and it turned out to be a useful feature for the greater user base of PgBouncer.
That's great.
Awesome. Well, let's dive in.
Okay, so let me show up my demo. Let me first show you how the search path gets mixed up when there are concurrent clients in the transaction pool mode of PgBouncer. So here on the right side of my screen, you see a configuration file of PgBouncer, which sets the pool mode to transaction. And let me run PgBouncer here. And on the right side, I will create two connections to my database through the PgBouncer to simulate two concurrent application case. Okay. Now let's say the first application or the client sets its search path to tenant 1. And it will work fine. And the second application will set it to tenant 2, and it will work fine for the second connection. But when we go back to the first one, we see that its search path got overridden by the second client. So this is actually a well-known, well-documented limitation of the transaction pooling mode, and which is session variables are not supported in this pooling mode of PgBouncer. The thing is, with the session pooling mode, there is one-to-one correspondence between the applications and the processes that are serving them. So it is 100% compatible with Postgres. But with with transaction pooling mode, a single process may serve multiple clients, and clients share the session states and override each other's settings.
And so this is how it used to work, correct?
Yes.
Okay.
Or if you don't apply our fix or our
Okay.
configuration, that fixes this issue. Now I stopped PgBouncer and we'll show you how we fix this. So what we did is we added a configuration parameter to PgBouncer, which is called track extra parameters. And this is a list of session variables. Let's say you can put more. When you put stuff here and run the PgBouncer with this setting in transaction pooling mode again, we track the settings per client and they don't get mixed up. Let me run my clients again. And I will show you that now the same scenario again. First client setting to tenant 1. Second client setting to tenant 2. And when you go back, we see that the search path does not get overwritten. So well, how we did is once you specify which variables should be tracked or like preserved per client, internally we cache them per client and restore the state before the client runs any query under the hoods. So this improvement is in the open source code base of PgBouncer and available in the latest release, which is 1.20. That's it.
That's awesome. So I know PgBouncer doesn't really like parse the queries and also doesn't really parse set commands. So like how does it actually know the value of the search path that it should send?
Yes, it is actually using the one thing in the Postgres protocol. When you set a variable, Postgres sends back the changed value in a status packet, let's say. So PgBouncer is using that value to keep track of the value, changing values. So it is depending on Postgres reporting back the changed value.
Got it.
For a set command.
And so it doesn't do that for all settings.
True. If the value is not reported back, there's no way to keep track of it.
Got it.
Because as you said, it is not really parsing any queries.
And there's a question in the chat about whether the PgBouncer fix has performance impact for clients, for applications.
Yeah, good question. Actually, every time a client sends a query, we are restoring its state by appending a few set commands, like setting the values of the variables. So this is some performance impact, but it is negligible given the performance benefits of PgBouncer. Also, with the search path, I remember seeing some recent performance improvement proposals in the PG hackers. Hopefully that would improve further.
Awesome. And I know you said a second ago that this PgBouncer change is in version 1.20. So I just wanted to pop that release page from GitHub for PgBouncer up on the screen for a second. And the particular feature that you talked about that you did the demo of is this one that I'm highlighting right here with introduction of track extra parameters, right? So if people want to dig in more or investigate this, learn more about it on the PgBouncer side, this would be a place to start.
Yeah, this was great, and thanks for implementing it as well, because like this just makes the whole schema-based sharding experience a lot nicer, because it'd be terrible if you couldn't use PgBouncer, because it's such a useful tool. So this is amazing.
Thank you for joining us, Amel. Awesome demo. Really appreciated it. So, Marco, I think we're getting close to the end. I think there's a couple things that we should probably share for people who want to dig in or learn more. I'm going to go back over to here and click on the blog post that you wrote and was published a couple of weeks ago. So super useful overview of what's in 12.0. And I feel like this complements the way you write the blogs and you kind of explain things is a good complement to the updates page, which is also on the Citus open source project website, which is the nitty gritty detailed release notes. So those two things are the places that I would start.
Yeah, and there's also there's a few things in Citus 12 that we didn't talk about here, but I mean the blog post does cover them, and the updates page does as well. For example, Postgres 15 introduced merge, the merge command, where you can do in one command inserts, updates, and deletes depending on the existing values. And we've been slowly chipping away at making this work very smoothly with distributed tables in Citus. And so now we have the capability to also, if we need to do a reshuffle because you're doing a merge between two tables that are not co-located with each other, that now works pretty seamlessly. So there's still a few open items, but merge is becoming another kind of distributed database superpower in Citus. So that's pretty awesome.
Another feature we didn't talk about today was the size-based shard rebalancer.
Yeah. So it's not a new feature, but we now switched the default rebalance strategy, as it's called, to by disk size, and that means that as owner was showing, if you have one shard that's much bigger than others, the disk size rebalancer will figure that out and weigh that shard accordingly, such that it all the small shards go, or the small schemas go on one node, and the big schema goes on another node. So that's now the default. In the past, the default was always shard count based. So we put 2 shards on one node, 2 shards on another node. But we found by disk size to almost always work better in practice. So that just makes it again a little bit easier to use.
Awesome. And then on the left hand side, if any of you Citus open source users ever want to dig into what was new in 11.3 or 11.2, you can navigate through there with all of that. I also wanted to pop up our GitHub open source repo on the screen quickly. That's a great place to file issues, give feedback. There's a new-ish discussions tab. I don't think we have a lot of discussions there right now because we didn't even have the tab up for a long time, but people are welcome to pop in there too. Is there anything else that I wanted to be sure to highlight? Oh yeah, I just wanted to reiterate something you said earlier, Marco, which is you basically said, look, the traditional way that Citus has sharded Postgres, we didn't have a name for it before because it was the only way that Citus sharded Postgres. And we're now introducing this name for it, which is row-based sharding, because we needed to differentiate it from the new thing in 12.0, which is schema-based sharding. So on the product overview page, we kind of have this nice diagram that features row-based sharding on the left and schema-based sharding on the right, and tries to help you understand the choice that multi-tenant SaaS developers have between these two approaches. Is there anything else you want to highlight about that, or?
Yeah, and I mean, for certain applications, it's just clearly one or the other. Large tables, row-based sharding, lots of different tables, probably schema-based sharding. But yeah, multi-tenancy, there's trade-offs to consider. So we the blog post also discusses it, and it's good to consider those trade-offs. And then know that if you just want it to be as easy as possible, schema-based sharding is definitely the easiest way to get started.
Cool. download page on the website if you want to go kick the tires. There's instructions for all the different operating systems. And obviously you'll be installing Postgres as well as the Citus open source extension together. And then all the open source docs are still here online, and you can see the v12.0 in the upper left now. So
and also if you want to talk to us directly or chat with us directly, like we're always hanging out on Slack. You can join via slack.citusdata.com. There's also a lot of other Citus users that are answering questions and asking questions. So that's a great channel. Also, Stack Overflow, we monitor it for Citus questions. So feel free to ask things there.
And I want to thank everybody who joined us today to give demos. I want to thank Owner and ML and Gokhan for joining us. Maybe we can pop them up on screen so they can wave goodbye. And for all of you who are watching it live, or more likely, most people like to watch these kinds of demos on their own schedule, on their own time. So for people who watch it later, thank you very much. And yeah, questions always welcome. Feedback is a gift.
All right. Thank you.
Thanks, everyone. Ciao, ciao.